Established as the second tertiary institute to produce graduate engineers, the Nanyang Technological Institute is committed to providing a practice-oriented engineering education to meet the demands and challenges of Singapore's fast-growing high-technology industries. As a reflection of this commitment, each year, the School of Civil and Structural Engineering incorporates in its 10-week in-house practical training program a unique and ambitious project, namely the construction of a full-scale structure. This project, which takes place after the end of the second academic year, aims to simulate real construction practice so as to enrich the students' experiential learning on almost every aspect of civil engineering practice.
In 1983, the first in-house training project was the construction of 5 reinforced concrete sheds with hyperbolic paraboloid roofs, which now housed part of the CSE construction laboratories.
Last year, the task was to build a 30-meter-long spectators gallery for a sports ground in the campus. We shall present to you the highlights of our third construction project for this year's in-house training, a multi-purpose James Arena Gallery situated in the vicinity of NTI's sports complex.
This simulated exercise to manage and complete a construction contract enables our students to gain an appreciation of the management and office skills required, the actual manual work at the site, and the geotechnical aspects involved. All these various facets of the training will be put to the test in this morning's final presentation. Meticulous planning and preparation by the academic staff were essential to bring this project to fruition. Before the construction project began, necessary documents had to be produced. Utilizing the latest electronic gadgets in the computer laboratory, the structural design of the gallery was carried out and the results were checked before transforming them into the drawing. The drawings were prepared and then stored in the computer. Hence, they could be retrieved later for further usage or change. All these were made possible by the computer-aided design and drafting process. The drawings could now be conveniently reproduced. The master plans detailing the design and implementation of the project were encapsulated into 3 major documents. The academic staff conducted supplementary lectures on various aspects of planning and construction which our students had not yet acquired in their second year of studies.
To implement the building construction, the students were grouped into 7 construction companies. Each company registered itself under a different name and was responsible for the construction of 1/7 of the gallery. Each construction team was further subdivided into 9 groups. In any one week, one group became the management group, another the office groups, and the remaining 5 groups the site groups. The various roles were rotated every week so that every group had the chance of participating in every aspect of the construction.
The management group was responsible for project planning, resources scheduling, quality control, safety enforcement, and materials and cost control. The students used microcomputer programs based on critical path methods for more effective control of the construction process. Every Saturday morning, progress reports were presented by the management group to the rest of the team members, and together they review difficulties or problems encountered during the week. The office groups provided the administrative and engineering support to the management group in preparing materials estimates and bar bending schedules, designing temporary works, accounting and updating of work programs. The site groups as workers were responsible for the correct and accurate execution of the works, and this hands-on experience provided the students with a unique insight into the demanding roles of a site engineer.
The students were also given some experience in financial management, similar to that in the real world. Initially, Each company was given a floating sum of $4,000. They were required to keep accurate account of expenditure and income. Each company was charged for all materials and small tools requisitioned in accordance with standard unit rates. Plant hire was charged on an hourly basis. To encourage the students to solve their own problems, an hourly consultation fee was levied for consulting the staff in charge of them.
The project involved the construction of the gallery structures, which consisted of reinforced concrete footings, walls, connecting beams and slabs, columns, and cantilevered roof. Before the excavation for the footings could commence, the construction teams had to set out the positions of the proposed footings. No excavation for footings was allowed before its setting out had been checked and approved by the staff in charge of surveying. A mechanical excavator was used for the excavation. Finally, the bottom of the excavated pits were trimmed using manual methods.
Whilst the excavation for the footings were being carried out, the remaining members of the construction teams were either cutting and bending steel reinforcement for the various structural components and fabricating formwork in preparation for the casting of the footings. Before any concreting was allowed, all steel reinforcement and formwork had to be checked and approved by the Quality Control Committee. To expedite the concreting operation, ready mixed concrete was used. The concrete was spread by charcoal before the vibration was started. A polka-dot vibrator was used to compact the fresh concrete. Full compaction was ensured by vibrating it for an adequate period of time.
The students were required to check the quality of concrete used. Concrete cube tests to ascertain the strength were carried out regularly. No shoddy work or error was allowed to pass. One team had to hack an area of honeycombed footings and then rebuild it. On completion of the footings, the preparatory work for the casting of the walls began. This included steel fixing and formal erection. Steel bars were cut to the correct length, bent, and then brought to the final locations for fixing and tying. Erection of formwork entailed careful checks on the verticality. All joints in the formwork were tightly clamped to prevent the loss of cement grout during concreting.
When the support walls were constructed, the excavated ground was filled and compacted accordingly. Formwork for the connecting floor beams and slabs, all designed by the students, was checked by the staff members of the formwork committee before permission was given for its fabrication and erection. The erection of formwork was thoroughly checked by the safety team comprising 5 academic staff. At least one safety officer was always on site to enforce safety procedures and rules throughout the construction period. Once all the reinforcement and formwork for the beams and slabs had been positioned and checked, they were thoroughly cleaned. The concrete was placed by means of a crane and skip. The concrete was evenly spread and compaction of the concrete was meticulously executed. Eventually, the concrete surface was leveled to an acceptable finish.
For the construction of the columns, tubular steel scaffolding was erected to assist the positioning of the reinforcement and formwork. Each column was carefully checked for verticality and height. All lapping of column reinforcement was ensured to be of sufficient length. Meanwhile, the remaining team members were busy constructing the drainage works. The precast channels were carefully laid and aligned. An inspection chamber for the drainage line was also constructed, and it was done in bricks. On completion of the brickwork, plastering of the surface was carefully executed.
At this time, the construction of the staging for the roof formwork was underway. With the project nearing completion, every effort was put in by the students to complete their work as soon as possible. The formwork for the roof beams was constructed, followed by the laying and tying of the steel reinforcement. On completion of the slab formwork, the joints in the formwork were sealed with paper tape to prevent the leakage of cement grout during concreting. For easy removal of the formwork, mold oil was evenly applied on the timber surface. Welded wire mesh was used as reinforcement for the roof slab. This was placed in position and secured with galvanized wire. After the reinforcement for the roof beams and slabs had been checked and approved, concreting for the roof was carried out.
Curing was then carried out by placing wet gunny sacks on the surface of the green concrete. Removal of props and striking of formwork commenced after the concrete had attained sufficient strength. The completed multi-purpose games arena stands as yet another outstanding achievement by second-year students of the School of Civil and Structural Engineering.
Apart from this arena construction, the students were also given the opportunity to be involved in geotechnical works. Each team was required to conduct a geotechnical feasibility study for the construction of a reinforced concrete gallery within NTI campus. The scope of work covered field investigation, laboratory investigation, geotechnical analysis, and project evaluation. This exercise provided the students with the insight of in situ testing and sampling, various laboratory soil tests, and geotechnical analysis.
Today's formal presentation by representatives from each of the 7 construction companies marked the end of a 10-week in-house practical training. You will soon witness yet another memorable event. Each of the 7 construction teams will be pitting their technical expertise, their recently acquired construction experience, and their presentation skills to the selection panel to secure the contract to design and build the proposed performing arts complex in NTI campus. This performing arts complex will be located in this area where the pond is. The complex will comprise a performance platform, spectators gallery, changing rooms, washrooms, footpaths, and footbridges.